Hi everybody, Patrick here from Engineering Shock Electronics. That's engineeringshock.com, vtagtargets.com, and escaperoomelectronics.com. Links below. This is the 8-button transceiver module, part of a Kickstarter campaign, the NRF24L01 Plus Kickstarter campaign for I created a shield and a bunch of other boards, and this is the 8-button board. And what we're going to do is we're going to talk about how it works. One is set up as a transmitter, one is set up as a receiver. As you can see, I've got the 24L01 Pluses plugged into the board. It's got a 100 microfarad electrolytic capacitor soldered directly to the leads. Now, as with the other modules, there is a capacitor on the board on the 3.3 volt line, but these modules are really specific. They really do work better when they have the capacitors directly on the 3.3 volt and ground leads. So, that said, let's quickly talk about the hardware. We've got 8 buttons. We've got an output rail. The output rail is used, it can be used on the transmitter side. It can be used to apply logic to transmit. Alternately, you can use the buttons. On the receiver side, the pin headers act as an output. So what we can do is we can have up to 64 transmitters transmitting toward one hub receiver. So we're going to set one up here as a transmitter, one as a receiver. They both use 2 different pieces of code. What you do is to upload the sample code, you take your Arduino Uno, you unplug you program in your the code into your ATmega328PU chip, pop it out of your Arduino Uno and pop it in here. All of these units will come with their own chip with a basic program already added. So when you program a receiver, what you want to do is you want to remove this header. So as you can see, this one is our receiver. It has no jumper on that header. There's also all of your units will come with a 2-pin header. Jumper jumping the middle and 5 volt pins and leaving the left open. I'll zoom in on that a little bit later. I'm getting ahead of myself. So the idea is we've got an address dip switch, and currently they are all set to the off position. On the underside of the board, they're labeled 1, 2, 3, 4, and 5, and 6. When you match the address, let's say we have them all in the off position, then the transmitter will send data, and the receiver will receive it and decode it and say, "Yeah, we're a match." But if I set one of the dip switches to a different address than the receiver, then the receiver will reject any data sent by this transmitter. So I say we can have up to 64 transmitters as long as the address set up on the dip switch equals the same address on the receiver. So, lastly, just to talk about this, again from the left to right, labeled 1, 2, 3, 4, 5, and 6. 1 is worth 1, 2 is worth 2, 3 is worth 4, 4 is worth 8, 5 is worth 16, and 6 is worth 32. So you can have 64 different transmitters, again talking to one receiver. So, okay, I've prattled on enough. Let's do a quick demo. So first I'm going to plug in my transmitter, and the red LED will turn on and off. Sorry, my power supply is pulling it back. And I'll plug in my receiver, and nothing will happen. No LED will turn on. Now, because I've got the addresses set to the exact same address, I can transmit, and it will be received. And that data is actually going to the outputs. And I'll show you that under oscilloscope in just a second. Now, button 8. Unfortunately, because button 8 is connected to pin 10 of the, or GPIO 10, which is being used as the chip select for SPI, because it's not being pulled high, it can't be used. But simply unplug the NRF24L01 Plus, change the software as you see fit, and you don't need to use this as a transceiver. You can use this module. Schematics will be provided for other purposes, and you can include button 8. So how do we get past button 8? We still want to send 8 pieces of data. So as you'll notice, quickly what I'm going to do is I'm going to watch the LED on the receiver. 1, 2, 3, 4, 5, 6. Now watch what happens when I press 7. There's a delay, a quick delay, and that's because it's sending button 7 data when I tap it, but when I press hold and I let go, then it sends button 8 data. So what do you mean by button 8 data? I mean these outputs are actually being set for a very short period of time when it receives data. So in this case, if I press button 1, then output 1 here will be asserted or set for a certain amount of time, then cleared. Now, if I change the address on the fly on either end, let's say the receiver, if I change the address, they're not matching, what will happen is it will still blink saying it's received, but it won't be decoded, and nothing will happen on the output. So what I'm going to do is I'm going to switch it back so that the addresses match, and I'm going to show you what happens on the oscilloscope. So I'm probing output 1, and I'm pressing button 1 on the transmitter, and the addresses are the exact same. And we get a 100 millisecond pulse. So I'll clear that. And what I'm going to do is I'm going to change the address, and I'm going to press button 1 again. Nothing happens. I'm going to switch it back, press button 1, and there we go. We get the 100 millisecond pulse. So you can use that pulse to do whatever you'd like. So as you can see from the right to the left, we've got 1, 2, 3, 4, 5, 6, 7, 8 ground and 5 volts. So again, if I'm probing, on the receiver, if I'm probing pin 8 and I press pin 7, I tap pin 7, nothing will happen. If I press and hold pin 7 for 500 milliseconds and then let go, we'll see button 8 data. So there is a regulated 5-volt line here that you can access to power other low-power devices and to ground. So you can use this rail not only as an output to an external device to control an external device, you can actually power it with a 5-volt line. Don't apply more than 100 milliamps, but yeah. So another low-power device. So I've got pin 8 probed on the receiver, and I'm going to press button 7. And I'm going to see what happens on the oscilloscope. I'm going to press button 7, tap it, nothing. I'm going to press and hold it and let go. Yeah, and there's the 100 millisecond pulse. So that's how I've compensated for the button 8 problem. And again, you can use this device for other purposes that actually do include button 8. It's just because the SPI doesn't appreciate being set as an input without being pulled high, that is a bit of a problem. So that's easy enough to counter. Let's talk a bit more about that jumper we talked about earlier. So as you can see, right back here, we've got the 3-pin header, and the jumper is jumping the top 2 pins from this perspective. If you're assembling one of these yourself, or if that jumper is not connected, then power will not be provided to the NRF24L01 Plus unit. Now we've got a power jack right here. 9 volts is ideal for this set. Most of the rewards come with a 9-volt power adapter. There's also an option, a terminal block option, that allows for you to wire in your own power supply if you want to. Left is labeled 12 volts, right is labeled GND. So you can actually use 9 volts, or 9 to 12 volts, doesn't really matter for this unit. I would suggest 9, but 12 is just fine as well. It's a low power unit, very low power. So apply 12 volts, 9 to 12 volts to the left terminal. Just use a screwdriver, unscrew it, plug in your wire, screw it back in to tighten it, and your DC ground on the right, and that will power the unit aside from the power jack. So as for the L01 Plus, the 24L01 Plus, has 8 pins. Make sure, double check that once you've connected it, that it does line up perfectly from both sides. You don't want to make a misconnection there. Yeah, and that's it. That is it. It's very simple to use. You can have up to 64 transmitters on one receiver. You can also use these 8-button units to talk to a shield. There's another video on that talks a bit about that too, but it's all based on addresses. So I hope this video has been educational. I'm sorry if I rambled a little bit. I tend to get a bit excited about such things. This is the last video manual. If you want to see the relay board or the motion sensor board or the shield sensor board videos, check out my channel. These videos are made just right at the beginning of 2019, January 2nd. So thanks for watching, everyone. I hope you have a wonderful day, and Happy New Year.